So today we are going to talk about an interesting coding problem, that is to generate a random number from 1 to 12 using a function that returns a random number from 1 to 6. So what I have noticed is many people use loops and conditions and various other methods to solve this problem. So that approach may fetch you a result, but it gets pretty complicated and is unnecessary, I think. Now, the point of this problem is to use mathematical operations to solve this problem. So the approach we are going to cover is pretty simple. It's our two-liner solution. Using this solution, you can solve this problem as well as any other variations of this problem exists. So here I have my editor, and first thing we are going to do is implement our initial rand6 function, which should be already provided. Okay, so this is our rand6 function, which is going to provide us with a random integer from 1 to 6. Now let's write our real code, rand12. So it's pretty obvious we are going to need at least two calls to the rand6 function. Let's do that. A is equal to rand6, B is equal to rand6. So here we have two variables a and b, both having random integers from 1 to 6. We define a variable c, which is gonna be a solution, that is random number from 1 to 12. Now first thing we can do is a plus b, and let's write a minus. We can multiply this by 6. So what we are doing here is our b is a random integer from 1 to 6, and this is gonna be added to a. A is 1 to 6 and minus 1. So we are doing minus 1 to fetch 0, which is gonna be a random value from 1 to 6. So for 1 to 6, it is dependent on b, whereas the other value from 6 to 12, it is coming from a. C is equal to c modulus 12. 1. So here we are doing modulus 12 and minus plus 1. So modulus is the key here. Basically any such problem where you have to limit a number to a range, and modulus is almost always the answer. So here whatever number we have generated, we are gonna modulus by 12 and plus 1, because modulus of 12. So if we do any number modulus 12, any number that is divisible by 12, the remainder is 0. That is modulus is gonna be 0, and we don't need 0. That's why we have plus 1 here. Now here we are gonna write return C, and that's it. So basically this two-liner operation is gonna use your rand6 function twice and generate a random number from 1 to 12. So let's try this. So let's try to run this now. Okay. So as you can see, we have numbers from range 1 to 12. But now how can we ensure that we are covering all the range and everything? So let's try to cover that manually. So to test this approach, what we can do is, instead of getting value of a and b from rand6, we can pass every permutation combination of a and b manually. So let's modify this function. A is equal to none and b is equal to none. If we pass the value to rand12, we use that value, else we are going to use rand6. Now let's loop through every possible permutation and combination. So So now let's run this solution and okay. So here we have all the permutation combination. Let's check the probability. So here we can see some values are repeated multiple times. Now in such case, is it truly a random? So to check probability of each number is same, we are gonna implement a counter. So what we have done here is declared a variable with 0 as all the values, and on index we have incremented the value by 1, and then we have printed the array. So let's see. Okay, so this first one is a 0 index and 0 is not there since we have to generate from 1 to 12, and as you can see every number is generated 3 times, and that is gonna be our equal probability. And so there it is, two-liner solution without using any loops or conditions or anything, purely on a mathematical approach. So now let's cover another variation. There is another variation for this problem, that is from rand7, that is a function that generates random number from 1 to 7, generate random numbers from 1 to 10. So let's try the same approach. We are gonna change. So let's edit this rand7, and this is gonna be 7. So here you can see we have changed it to rand7, and now we are generating random number from 1 to 10 using a rand7. So let's check the probability. Okay, now here are all our combinations. This is gonna be 8. Oops. Yes. So now we have all the combinations here till the 7. So as you can see from 1 to 10, that is here, all are 5 except 1, that is 4. So the probability of coming 1 is very slightly less than other numbers, but it is almost negligible. So there you have it, a pretty simple two-liner solution to this problem. Now remember this, in case of any such problem where you have to limit a number output in a range, always think of modulus first, because modulus is the key in such operations. So that's all, and let me know if you like this solution.